Hello, dear students. Today's lesson, we're going to talk about the oscillating circuit. What is oscillating circuit? A circuit, it is made up of a cell of inductance and capacitor without resistance. Connected. If the capacitor is initially charged under an external DC source, because the capacitor is charged under a DC source, not AC source. Okay, then the circuit will oscillate. Okay, so how this occur? Now I'm gonna draw a circuit. At first, we have to connect DC battery, DC source. This source is DC. Okay, connected with capacitance. Okay. And then the capacitor connected with inductance. Now, under this DC source, the capacitor will be charged and all positive charge accumulate here. Okay, and the negative charge will accumulate here. Now, the capacitor is charged. Q is equal to Q naught. It means that the capacitor is charged under DC source and the flow of the current is zero. Flow of current is what? Now, the flow of current is zero. Okay. Now, we can remove the source. Okay. We can remove the source. What does remain? Only the capacitor and cell of inductance. Okay. Now, after this, when the capacitor is tried to discharge, okay, when the capacitor becomes discharged, now what happened? Look, the current flow into the inductance. Okay, when the capacitor discharged, Q is zero, but I, it becomes IM. What do you mean by that? It means that the charges flows and the current will occur. Okay? So the current, when the current passes through the coil, what happened? The electrical energy is converted to the magnetic field. Okay? But in the case of the capacitance, what type of the energy is stored? The electrical energy. Electrical energy is stored in capacitor under charged by DC source. Okay, after the capacitor try to discharge, the current flow into the inductance, and this electrical energy is converted to the magnetic field. So the energy is stored as a magnetic field in the conductor. Okay, according to this equation, magnetic field is equal to mu naught N I over L. When the current carrying into the solenoid or the inductance, the magnetic field will produce. Okay, so this process will continue. After the current is converted to the magnetic field, so this magnetic field also induces the current according to the Faraday's law. The magnetic field also induces the current. So this induced current passes through the capacitor. The capacitor again becomes charged. So the figure becomes like that. Now, through the magnetic field, the current is induced. At first, the current is induced. The current passes through the coil. Magnetic field is induced. So this magnetic field also induces the current. I induce. Okay. So this current passes through the capacitance. Okay. So the positive charge now accumulate here. Okay. And the negative charge will accumulate here. Again, the capacitor becomes charged. Okay. After that, this charged capacitor will be discharged and the current flows into the inductance. So this process will continue. So this process is called the electric oscillation. What is the electric oscillation? Is the exchange between the electric field and the magnetic field. Okay. And you can Draw the diagram of the current. At first, current is 0. Okay? When the current passes through the coil, it reaches maximum and also becomes 0 in the capacitor. So this oscillation is called what? The electrical oscillation. Okay? If the initial charge on the capacitor is Q naught, then the electric energy is stored in it as electric field. So when the capacitor is charged, the energy is stored as what? Electric field. But when the current carrying into the inductors, the energy is stored as a magnetic field. Okay? The capacitor discharged through what? Through the coil. While the current increases to achieve its maximum. The current achieves its maximum. Okay? Now here, the magnetic field is stored. And the energy is now stored in the coil as a magnetic field. So this process will continue, but in the presence of the resistance of the coil, because if the coil is not pure coil, some of this current is converted to heat. It means that the damping will occur. When does the damping will occur in the electric oscillation? In the presence of the resistance in the coil. In the case when the coil is not pure coil. Okay? But for pure coil, if you assume that for the pure coil, no damping will occur, the circuit will oscillate indefinitely. Okay? So the charge is again restored by the capacitor until the current in the coil drops to 0. So when the capacitor becomes charged, the flow of the current becomes 0. But when the capacitor tries to discharge, the current reaches maximum value. Okay, so the energy is again stored in the capacitor and so on. The exchange of energy repeated many times between the capacitor and the coil, as long as no part of it flows through the resistance of the coil in the form of heat, the electric circuit will oscillate for infinity. Okay, if resistance is 0 of the coil, then no damping will occur. When does no damping will occur? When the resistance of the coil is 0, pure coil. When does? In the case of pure inductance. Okay, so the resonance circuit, the circuit will oscillate indefinitely. Any possible energy loss in the case of the presence of energy loss or resistance, or when the coil is not pure coil, any energy loss possible leads to what? The damping. When does the damping will occur? When the energy is loses or when the coil is not pure coil. Damping of oscillations such as resistance in the coil, not pure inductance, part of its energy will convert to what? To heat. If a current of the same frequency and phase is introduced in the circuit, resonance will take place. When does the resonance take place in the electric oscillation? When the frequency of the external AC source matches or equal to the frequency of the oscillating circuit. In that case, we can achieve the resonance. Okay, so resonance will occur only with AC current. Why? Because AC current has frequency. In the electric oscillation also we have frequency. If these two frequencies are matches to each other, the resonance will take place. Okay. Why the resonance will not occur with the DC source? Because DC has no frequency. Okay, so that is why we cannot achieve the resonance. Okay, electric oscillating is the process of what? Exchange between what? Exchange energy between capacitor and inductor. Between capacitor and inductor. In capacitor as electric field, in inductor as a magnetic field. Energy stored as an electric field in capacitor and energy stored as a magnetic field in a coil. So the frequency can be found by using this equation. Frequency is equal to 1 over 2 pi LC. Okay. So what does the frequency of the oscillating circuit depend on? It depends on the coefficient of self-inductance, inversely proportional, and the capacitor of capacitance. So the relation between F is inversely proportional to the radical L So frequency also inversely proportional to the radical of C. What do you mean by that? It means that by increasing the inductance, the frequency of the oscillating circuit decreases. And also for the capacitor, when the capacitance of the capacitor decreases, the frequency will increase. When the capacitor or the capacitance increase, the frequency will decrease because they are inversely related to each other. So what causes oscillating damping in an oscillating circuit? Resistance. In the presence of the resistance, the damping will occur. Okay? So how damping will occur? The current decreases at first, has maximum. When does this damping will occur? When resistance is not equal to 0. Okay? But in the case when resistance of the wire is 0, the current will oscillate indefinitely. So when does this indefinitely oscillating will occur? When resistance of the coil is equal to 0. Okay? And due to the resistance of the coil, some of the energy loses in the form of heat. And what is the resonance? Electric resonance? A phenomenon that occurs. A phenomenon that occurs. When does it occur? When alternating current with a given frequency enters the circuit that has the same frequency of the circuit current. Thus, the frequency of the current source is equal to the frequency of the circuit. If these two frequencies are matches to each other, the resonance will occur. According to this equation, what does the frequency of the resonance depend on? Cell of inductance and capacitor. The resonance will occur by changing what? By changing three factors. We can achieve the resonance. Frequency of the AC source, by changing the frequency of the given source or given AC source to the circuit, by changing this frequency, you can achieve the resonance. And also by changing the capacitor and the inductors. Okay, by capacitor of capacitance or coefficient of cell of inductance. But this one is not very practical. Which one is very practical? By changing the capacitor. That is why sometimes we say variable capacitor. What do you mean by variable capacitor? It means that we can change or we can control the magnitude of the capacitor. So which one easier to control or to change? Coefficient of cell of inductance or capacitor of capacitance? Capacitor of capacitance. Okay. What is the condition of resonance to occur? When the alternating current with a given frequency have the same frequency of the circuit's current. Okay. What does the resonance circuit is made up? It's made up of cell of inductance and variable capacitor. In the case when XL is equal to XC in the circuit, the resonance will take place. Okay? One of the conditions of the resonance is XL is equal to XC. As you know, XL is equal to what? 2 pi FL. What about XC? 1 over 2 pi FC. Cross product. Okay? 2 times 2, 4. Pi squared. F times F squared. LC is equal to what? 1. By rearrange this equation to find F squared, so you have to take 4 pi squared with LC to the denominator. It becomes 4 pi squared LC and 1 is in numerator. So you have to remove this square because we have to find the absolute frequency, not the square frequency of the circuit. Okay? F is equal to what? The radical of 1 is 1. Radical 4, 2. Radical pi 2, pi. Radical L, C, L, C. So this is the proving of the equation of the frequency, to finding the frequency of the resonance circuit. So how can you produce the resonance phenomenon in electric circuit? In electric circuit, so the circuit is entered into the resonance when a current of a given frequency is entered to it, while the capacitance of the capacitor is adjusted to what? To achieve the resonance. Equal the frequency when the capacitance of the capacitor is adjusted to the equal of the frequency of the current of the circuit. This is how one can tune the frequency of radio and television station at home. When the resonance takes place, the reception of the broadcast station is possible. What is tuning? Is the act of achieving what? Achieving resonance. Okay? Between the frequency of the radio and the television station at home with the reception of the broadcasting station. When does the reception of the transmitted waves occur at broadcasting station? When the resonance takes place and the reception of the broadcasting station is possible. Okay, we have some notes about the resonance. The properties of the series circuit at the resonance. For the circuit that connecting in a series connection. So another condition of the resonance to be occur is XL should be equal to XC. Okay, the inductive impedance must be equal to the capacitive impedance. Okay, so in that case, when inductive impedance XL is equal to XC, when XL is equal to XC, in a series connection to find the total impedance is equal to radical R squared plus XL minus XC squared. So in the case when these two factors are equal, XL is equal to XC, they become 0. Okay, 0 square 0, R square and the radical they remove. So what is remain? Z is equal to R. So it means that in a resonance, the magnitude of total impedance in a series connection is equal to what? Is equal to R. Okay, so in that case, the resistance decreases and the impedance also decreases. So the current has maximum value. Okay. So in the resonance circuit, the phase difference is 0. Why? Because XL and XC, they cancel each other. This is XL and XC, so this is R. In the resonance circuit, XL is equal to what? XC. Okay, so these two vectors are in opposite directions, so they cancel each other. What is remain? Only resistance will remain, and the phase, the angle of the total potential difference and the current is equal to what? 0. One of the conditions of the resonance circuit, the angle between the total potential difference and total impedance with the resistance is 0. They are in phase. Potential difference across inductance and capacitance also is equal to 0. XLC also 0. V total also is equal to potential difference across the resistance. VL is equal to VC. XL is equal to XC. When XL is equal to XC, omega L is also is equal to 1 over omega C. So this is very important. Be careful, please. The student, please pay attention. Maybe in the exam, they will bring which of the followings are correct for the resonance circuit. For the resonance circuit to be occurred. Okay? All are correct. When we say XL is equal to 1 or XL is equal to XC, sorry, XL is equal to XC, so in that case XL is equal to what? Omega L. XC is equal to what? 1 over omega C. Okay, so also this is the condition of the resonance. If you cross product, omega times omega, omega square, times LC is equal to what? 1. Rearrange the equation. Omega square is equal to what? 1 over LC. Remove this square by multiply the radical. What is remain? Omega is equal to 1 over radical LC. Okay? So when does the omega is equal to 1 over radical LC? In the case of resonance circuit. When the circuit has a resonance. So the phase difference between the potential difference and the current is 0. The current of the circuit will have maximum. Why? Because the resistance decreases. Okay? I is equal to what? V over Z. When the Z decreases in the case of the resonance, Z decrease, the current will increase. So that is why in a resonance circuit, the current has maximum value because the total impedance decreases. will have minimum value, then the circuit is connected in a series. The resonance frequency can express as follows: F is equal to 1 over 2 pi radical LC, and the circuit has characteristics of the pure resistance because XL and XC has 0. And in the resonance case, omega is equal to what? We proved with this equation, is equal to 1 over radical LC. As you know, the relation between frequency and capacitance is inversely proportional. Frequency is equal to what? 1 over 2 pi radical LC. What is relation between capacitance and frequency of the circuit? Is inversely proportional. Okay? What do you mean by that? It means that if in the question two capacitors are given, okay, or two frequencies are given, you have to use this relation. F1 over F2 is equal to what? Radical C2 over C1. Why? Why here we have 1 but here we have 2? Because frequency and capacitor inversely related to each other. In the case of inversely related between two variables, you have to write down F1 with C2, okay? And according to this equation, you can find the value of the changing frequency, okay? What does the impedance in a series circuit at a resonance depend on? It depends only on the resistance, because in a resonance circuit, the total impedance depends only on the resistance. It doesn't depend on the inductive impedance or capacitive impedance. Why? Because inductive impedance and capacitive impedance, they cancel each other. But in parallel circuit, at a resonance, the magnitude of the current has minimum value and the impedance has maximum value, because as you know that the process of the series connection with parallel connection are completely different to each other. So we prove with this equation. Look at this figure. This figure. How energy is stored in this figure? How energy is stored in this figure? As you know, the capacitor has 0 charge. Okay? It means that there is no electric field here. Okay? But current is maximum value. It means that the energy is stored in the conductor as a magnetic field. In this figure, the energy is stored as a magnetic field. Why? Because the magnitude of charge is 0. The current has maximum value. In the second figure, how energy is stored in this figure? How energy is stored in this figure? You have to take a look for the figure. Charge is 0? No. Charge has maximum value. But current has 0 value. There is no current through the inductance. That it means that there is no energy stored as a magnetic field. The energy stored as a electric field here. Okay? Electric field, but here magnetic field. The energy is stored as a magnetic field. Sample question 41 in a chapter review. Okay, if the below circuit, the circuit is given with its feeding current, what is the effective value of alternating current? What is unknown? The effective value of alternating current. E total is unknown. Okay, IE total is equal to what? Is equal to VE total over Z. Okay, so do we have Z? No, but we have resistance. Okay, so at resonance circuit, the circuit has resonance because the question says resonate. What do you mean by resonate? It means that XL is equal to what? Is equal to XC. And in the case of resonance, the magnitude of Z is equal to what? R. Do we have Z? No, but we have resistance. The value of the resistance has the same value of total impedance. So that is why, and the total effective current was given 220 divided by what? Z. Z is equal to R. Why? Because the circuit is connected in a series connection divided by 22. So the current is equal to 10 ampere. Okay? Because the circuit is at resonance, that is why Z is equal to what? R. When does Z is equal to R? In a resonance circuit. When the circuit is at resonance. Be careful, please. This is very important. And the magnitude of the current is equal to 10 ampere. Question 42. Very good question. Resonant circuit. The circuit is what? Is resonant. Is made up of inductive coil and variable capacitor. What do you mean by variable capacitor? It means that the capacitor changes. The capacitor can change. Okay, when the capacitor changes, what happens to the frequency? Also changes. So what is the relation between them? Inversely proportional. Increasing capacitance, it goes to decreasing frequency. Decreasing capacitance, it goes to increasing the frequency. If the capacitance of the capacitor is lowered, what do you mean by lowered? It means that, for example, F is equal to what? 2 pi radical LC. Okay? When the capacitor of capacitance is lowered, it means that it becomes smaller. What happened to the frequency? The frequency of the circuit should be increased. Why? Because they are inversely related. C1 was given is equal to 400 microfarad. It means that 400 times 10 power negative 6 farad. You have to convert this micro because it is not allowed to solve in question with micro. Okay. C2 lower it becomes 100 times 10 power negative 6 farad. Okay. What happens to the frequency? So in this question, without solving, just by knowing the given value of the capacitors, in this question, the frequency should be increased or decreased? Absolutely should be increased. Why? Because capacitance lowered, capacitance decreased here. That is why the frequency should be increased. By which factor? We have to calculate. Okay? What happened to the frequency of the circuit? So it means that F2 is equal to how many times F1? So we have to find this factor. How can you find this factor? By replacing to the equation. F1 over F2, as I told you before, when two capacitors are given, you have to use this relation. C2 over C1. Be careful. So F1 over F2 or F2 over F1, it's up to you, is equal to what? Is equal to C2 was given 100 times 10 power negative 6 divided by 400 times 10 power negative 6. Negative 6 cancel with each other. So what does remain? F1 over F2 is equal to what? 1 divided by 4. Okay. So by taking the radical, F1 over F2 is equal to what? Radical 1, 1. Radical 4 is 2. Cross multiply. 1 times F2. 1 times F2. F2. 2 times F1. 2F1. It means that the frequency in the second time is bigger than the frequency of the first time by factor of 2. Why? Because the capacitance is lowered. That is why the frequency should be increased. Okay? So F2 is equal to what? 2F1. So is it possible to write down the equation like that? F2 over F1, C1 over, yeah, it's okay. The same thing you can do like that. Okay? So this question is very important and very good question. And mostly of the students, they don't like this question because they said it is a very long question. So the trick of this question, this is mixed between the series connection of RLC circuit and the resonance. Okay, but this question has two branches. Branch 1 is about the series connection RLC series with AC source. The second branch is related with the resonance. Okay, but before solving this question, we have this note. Okay, you have to pay attention, please. if the coil's resistance and pure resistance are given in the question. What do you mean by that? If the coil's resistance and the pure resistance are given in the question, it means that if in the circuit the coil is not pure. Okay? What do you mean by the coil is not pure? It means that this coil has its own resistance. Okay? The coil is not pure. As you learned it in a previous lesson in our LC series connection, when the coil is pure or when the inductance is pure, you have to assume that this coil has no resistance. Okay? But when the coil has resistance and also the pure resistance is given, you have to find the total resistance. Why? Because total impedance is equal to what? R square plus XL minus XC square. So this resistance is the resistance of the coil or resistance of the pure resistance? Both. So this is what? This is the resistance of the coil and the pure resistance. How can you find the total resistance? Total resistance is equal to the sum of what? Pure resistance and the resistance of the coil. Is equal to what? The resistance of the pure plus resistance of what? Coil. This is very good point. Be careful, please. The resistance in the equation of total impedance is not the resistance only for the coil and is not the resistance only for the pure resistance. The resistance, this resistance is a total resistance. How can you find the total resistance? By adding them. Adding the resistance of the coil and the resistance of the pure. Okay? If the circuit is made of a coil with a resistance, okay, this is AC source is connected with what? This is the resistance of the coil, okay, and capacitance. What is this? This is capacitance, okay, and resistance. Okay, what we have? We have resistance here. This is pure resistance. What is this? Pure resistance. And what is this? Capacitance. And this is inductance. What about this resistance? This resistance is the resistance of the coil. Resistance of what? R coil. What do you mean by R coil? The resistance of the coil. It means that this coil is not pure. This coil is not pure. Why this coil is not pure? Because resistance of the coil is not equal to 0. It has resistance. Now, how many resistance do we have in this circuit? We have 2 resistance. Okay? R total is equal to what here? In the equation of total impedance, we have to use the R total is equal to what? The resistance of the coil plus resistance of what? Of the pure. Okay? Do we have resistance of the coil? Yes, 10 ohm. The resistance of the coil is 10 ohm. And the resistance of pure resistance is 12 ohm. R total is equal to what? Is equal to 22 ohm. Okay? So this is very good point. Before solving this question, it is very important for the students to know this information, okay? And to find the potential difference across the inductance, this is resistance and capacitance, coil with what? Coil with resistance. How can you find the potential difference across the coil? V coil. How can you find potential difference across the coil? In this coil, do we have resistance? Yes. Do we have inductance? Yes. It means that we have both resistance and XL, inductive impedance. How can you find V coil? V coil by using Pythagorean theorem is equal to what? VR square, VR of coil, plus, because we have resistance, plus VL squared, potential difference across the inductance. How can you find VR? By using Ohm's law. VR of coil is equal to what? I R of coil, and VL is equal to what? I times XL. After that, you have to replace into this equation to find what? Potential difference across the coil. Look, an RLC series circuit is made up of what? Coil of cell of inductance L, 15 millihenry. You have to convert to Henry, multiply by 10 power negative 3, and resistance 10 ohm. This coil has resistance. This coil what? Has resistance. Its resistance is equal to 10 ohm. This is the resistance of the coil. Okay, and the coil also has inductance. Okay, a capacitor of capacitance also is given. This is capacitor of capacitance is 200 microfarad, and resistance of resistance 12 ohm. What is this resistance? This is pure resistance. What is this? This is pure resistance. Look, in the circuit we have two resistance. What is the difference between these two resistance? This resistance is a pure resistance of the circuit, but this resistance is the resistance of the coil. Resistance of what? Of coil. Okay. Do we have potential difference across the resistance? Yes. V sub R. Potential difference across capacitance VC, and potential difference across the coil V what? V coil. The coil is pure? No, the coil is not pure coil, not pure inductance. It has resistance. How can you calculate VR? VR is equal to I R. Which R? Pure resistance, 12 ohm. How can you calculate VC? Potential difference across capacitance is equal to what? I XC, according to Ohm's law. How can you find V coil? V coil is equal to what? You have to use Pythagorean theorem. VR squared plus VL squared. Why? Because the coil is not pure coil. If the coil is pure, it means that has no resistance. V coil is equal to VL. VL is equal to I XL. But in this question, the coil is not pure resistance. Is not pure inductance. Has a resistance. So that is why at first you have to find the R total, because in this question we need current. In a series connection, the value of currents are equal. At first you have to find what? IE total is equal to what? VE total divided by Z. Do we have V total? Yes. What's given is equal to 100 volt. Okay. VE total 100 volt, and replace into the equation. But we have to find Z. How can you find Z? R squared, R total, plus XL minus XC squared. Replace into the equation to find the current, and the current, this current is also I sub C, I sub L, I sub R. Okay? For series connection, VR coil is equal to R times VR pure, this is not coil, this is pure, is equal to IR times resistance of the pure resistance. Okay, this is coil, and this is not pure, this is wrong. This is R coil. R coil was given 10. V across the resistance of the coil is equal to 43 volt. V across the inductance of the coil is equal to 24.3 volt. To find the potential difference across the coil, you have to use the Pythagorean theorem is equal to 49.4. And VC, as I told you, is equal to IC times XC. And VR of the pure is equal to R pure times IR is equal to 12 times 4.3. So branch B, the frequency of the alternating current that allows the circuit to resonate. We have to find frequency. Frequency is equal to what? 1 over 2 pi LC. Okay? 1 over 2 pi radical LC. Both the coefficient of self-inductance and capacitors are given in this question. So in the next lesson, inshallah, I will solve question 53 and we will study the transformer and efficiency. Thank you for listening. Hope you enjoy and get benefits from the lesson.